Hello everyone. Yesterday we talked about two methods to solve the two-sum problem. Today we are going to talk about the third one, which we couldn't cover last night, and look at like how can we even further optimize the solutions that we have, and what do we mean by memory complexity. We looked at time complexity yesterday. We'll look at the memory complexity today, memory space complexity. So I'm going to introduce a data structure today called as a hash map for this solution. Now, if you're listening for this word hash map for the first time, that's totally fine. I'll quickly go over like and define it for you, and then we will look at what is the logic for this solution that I'm saying that will take only big O of n time complexity. It will only like run in n complexity, and then we will like look at what numbers we see compared to the one we saw yesterday, where we were able to run it much faster than the n square, the sorting technique. We'll compare it with that, the numbers, and see where do we land. Okay, so let's get started. First of all, what is an hash map? So like you all know, like array is a data structure where you store things in an ordered fashion, like everything has an index, and like you basically do a traversal for the of the array whenever you have to look up something, like if there is an array like 1 2 3 4 5 6, it's an ordered collection, and everything has a specific index which cannot be changed as such. uh, uh, and when we say we cannot change that directly, is like we can obviously change it, but it is supposed to be kind of fixed without modifying the array. So if I go to the index 3, I can just directly say like array of 3, and that gives me the value that is at third index, right? And similarly, I can do array of 2, array of 1, and like that. You get the idea, like what is an array. Now, hash map is not an ordered data structure. What we mean by that is the you cannot traverse a hash map in any particular order. Okay, and what it is ultimately is basically a collection of key value pairs. Okay, like we have a key and a corresponding value. Like that's how we form a pair for the key value, and then there is like a sequence of these pairs that forms a hash map. And when we say it is not ordered, what we mean by that is when we try to traverse, if we try to traverse, then the order is not guaranteed. Like for example, let's say I have a hash map and I add the first key value pair to it. Let's say you're all students, so you all have a particular roll number that is unique for every student. And for let's say Atharva has a roll number 2, and like that's going to be the key that will be used to identify Atharva. And the value can be his entire record, like his name, his date of birth, his gender, his address, and things like that. So that student record is the value that is associated with this key, and no two students can have the same key, right? So Rishikesh would have a different roll number, Bharti will have a different roll number, and so on. So this entire collection is what we refer to as a hash map or a dictionary. And when we say it is not ordered, what we mean by that is we cannot traverse. There is like we cannot just go and directly loop over a hash map. The way we get values out of this is like we have like array of 3 or array of 5. We would do something like if this is a hash map, let's say student records. So student records. So I'm going to just simply just say student rec. I would have to give it a key. So I would do like dot get and give it a key, and that will give me the corresponding value. So the key could be anything, like let's say 4. So I want the record corresponding to roll number 4. So that's how I will get the record. But I cannot just go and do like for from so and so to so and so length, because like I can get the size. So the size for this would be 3 because there are 3 key value pairs in this. But I cannot go and say give me the value at 0th place or first place or second place. No, I cannot do that in a hash map. So that's why we say it is not an ordered data structure. So the key things to remember here are that it's a collection of key value pairs. Okay, and the keys are always unique in a pair. for a pair, the key has to be like there cannot be two records with the same roll number, 3 or 4. Okay, so that's what a hash map is, and it has certain special things related to time complexity which the array cannot provide us. Like for example, if I want to find a particular value in the array, I cannot directly ask the array give me 5 or give me 6. I have to traverse this array and check whether the value at this particular index is it equal to 5 or is it equal to 6. So any searching in an array is like usually it needs a traversal, and we know whenever there is a traversal involved, it is basically going to scale with the size of the array, and the complexity comes down to n. The time complexity comes down to n, and it's called as big O of n. Okay, but for a hash map, when we say like, okay, give me the record corresponding to roll number 2, we are saying the student record, which is the name of the hash map here, and we say dot get 2. So this operation, it happens in a constant time. Okay, it's a constant time operation. Now the inner details of how it is implemented can be looked up online, or we can have another video about that if you would like. But we can for now just consider the fact that any lookup in a hash map is a constant operation. That's why the complexity is called as big O of 1. So instead of traversing the whole set of keys, we can somehow simply just tell it, okay, give me the record for this key, and it will directly give it to us in a constant time, and the time complexity is big O of 1. Now, like I said, there are like inner implementation details for arrays and for hash maps and any other data structures. But Java already implements this data structure for us, and it is called as a hash map. The class is like naturally called as a hash map, and we need to specify what is the type for the key, what is the value for the key. Like for example, in this case, the key has a data type of an integer, while the value has a it's a user defined data type. You can call it as a student record or just a record. Okay, so like for this one, I would write something like hash map of integer is the key, and the value would be something like a student record. Okay, that would be the signature for this particular hash map. Now coming down to our problem, so we talked about the first thing, what is a hash map. Now we will talk about the logic, like how is this hash map going to help us to bring down the complexity from n log n or n square down to n. Now we know like whenever we traverse an array, naturally the complexity comes down to n, and because it is scaling with the size of that array. Now, but for this work, for the whole complexity to be n, the work that is happening at each step of that traversal, it needs to be constant time, right? So let's consider the same example that we were looking at yesterday, and the array was 10, 7, -1, 25, 30. Okay, so the logic here is going to be that what we'll be using that we will be framing our question in a different way here. So the question was like find two numbers, indices for the two numbers whose sum is going to give us the target. So if the target is 55, we are looking for two numbers x and y that give us the sum as 55. Okay, so what if we take this guy to the right hand side? What it becomes is x equal to 55 minus y. So this is how we will be framing the logic for solving this using this method. So what we are saying is, like, let's say we have a number y. We will subtract it from the target, and then whatever is remaining, that's the other number that we are looking for. So let's start traversing this array from 0th index, and the first number we pick is 10. So 55 minus 10 gives us 45. So if 10 has to be the answer, one of the answers, then the other number has to be 45. Now, how do we look for 45 in an array? Now, one simple brute force way would be to traverse the remainder of the array and see if there is 45 in that array. But that again would lead us to the n square time complexity, which we are trying to avoid. Okay, so let's see how the hash map can help us here. So in the beginning here, right here, the hash map is new, so it's empty. There are no key value records in that map in the beginning. But what we are going to do is, like, as we traverse this array, sorry, as we traverse this array, we are going to start keeping records of the numbers that we have seen so far. So for the beginning one, we haven't seen any number so far, so we don't have anything to look up for. So this first line here is basically trying to see whether we contain a key of target minus array of I, which is nothing but this thing. The target minus array of I is nothing but 55 minus y, and we're trying to see if that number exists in the hash map. Now, in like we haven't seen any number before 10, so naturally it does not exist. So we don't go inside this if. We come here, and what we do is we say, okay, let's put a key value pair entry inside the hash map. And what that entry is going to be, whatever was the number we are currently looking at and its index. So basically it would be 10 and 1. So the number, which is the key, and the value is the index. Okay, so now the first iteration is over. We come up here, we go do I plus plus, I is still less than array dot length. We come in inside again, and now we are looking at 7. And we use this equation here again. We do 55 minus 7, and we look if there is 48. Like 55 minus 7 is 48. So is there a 48? Have we seen a 48 so far? Like that's what we're trying to look for. And like how do we look that? This hash map. This is going to help us to look for that, because what we are doing here is we are keeping an entry of all the numbers that were there before the current index. And like as I mentioned, we can quickly see, like try to see like whether that hash map contains a key with 48. And since it's a big O of 1 operation, like a constant time operation, it will tell us no, it does not. So we again don't go inside this if. We come here, and now we again put the second entry into it, which is 7. And oh, sorry, my bad, this is 0, this is 1. And we move ahead. I becomes 2, still less than length, and we again check like 55 minus 1, which is 56. Do we have a 56? Have we seen a 56 so far? Then hash map says no. We still don't go inside this if statement. We come here, we put another entry, and we put like minus 1, 2, and this continues even for 25. Like 55 minus 25 gives us 30. We haven't seen a 30 so far. The hash map says there is no 30, so we go end up putting 25 inside with this index of 3. And then finally when we come to 30 and we do 55 minus 30, it gives us 25. And then we ask the hash map, is there a 25? And it says yes, there is a 25. So we come here, we see okay, there is a 25, and then we basically call this guy like get. So what we are trying to say here is get me the value corresponding to this key. So we give it the key as 25, and it gives us the value which is the index for 25. So one of the answers is this value 3, and the other is basically whatever index that we are trying to look for, which is 4 in this case. So we got the answer 3, 4, which is 25 plus 30 gives us 55. Let's see another look at another target to make this more concrete. Okay, so we will use the same array 10, 7, minus 1, 25, 30. This time let's take a target of 9, and initially the hash map is empty, the index is at 0, I 0. We start, okay, we tell, okay, again the same equation, 9 minus, this time it's 9 minus y, x equal to 9 minus y, the target minus y. So we do 9 minus 10, it is minus 1. Is there minus 1? No. So we put this entry, 10 corresponds to 0. We move ahead, come here. So 9 minus 7, it gives us 2. Is there a 2 in the hash map? No. So we move ahead, put this entry, come here. Okay. 9 minus minus 1 gives us 10. Okay. Is there a 10? Yes, there is a 10. Okay. So we get we end up inside the if statement, and now we have the answers. One of the answers is minus 1, which is our y, and the other guy x is 10. And we ask the hash map, okay, what is the index? It says 0, and the other index we have because of I, because our current I value is 2, so we have 2. So 0, comma 2 is the answer for the target of 9. I hope you understand like how we came to this answer, and how this looping is working, how the hash map is working. If you have any questions, please feel free to email me or ask it in the Google Classroom. Uh, and I will upload this video in Google Classroom. Uh, so let's look at like what the time complexity is, and what do we mean by the memory complexity here. So for the time complexity, we see that we are only traversing this array once, and the work that is happening inside this is a loop, is a constant time work, right? Like every statement here is complex, is a constant time operation. Looking up into the hash map is constant time, printing is constant time, and things like that. Putting into the hash map is again constant time. So we end up doing one traversal, and since we are traversing over n items, the complexity is big O of n. Time complexity is big O of n. But this is different from our other first two solutions. If you look at the hash map here, you will see like with every index we go, like we move forward, we keep on adding entries into this hash map. So like when we traverse when we traverse and reach this number 30, we had added like the first 4 entries into our hash map. So we can clearly say that this the number of entries is scaling with the length of the array. That's why it turns out like we are again using big O of n for memory, right? Because we are creating n key value pairs. So that's why the memory consumption for this problem is again big O of n. So that's how you optimize solutions. Like if you want to optimize for time, you will go with this solution. If you want to optimize for space, we will go with the like either of the first two solutions. And that's how algorithms work. Like today, since memory is really cheap, we are always happy to make this trade-off of memory versus time, and because we want to run things faster and faster. So that's the gist of all of it, and that's how it all works. Uh, I hope you understood what is a hash map in this example, and how are we using it to find out the two numbers. And this technique can be applied to a lot of questions. There will be a lot of array-based questions that you can use a hash map for, and make your brute force algorithms run much faster. But obviously, you will be consuming some memory space. So that's pretty much it. I will post some questions for you to practice time complexity and space complexity, and also like some array questions that you can try out yourself, that will be a kind of based on the techniques we have seen in this question, like how can you have a brute force of array for loop nested loops, can you use sorting, or can you use a hash map. So and so this pattern, like for us, it has come over practice. Like with some practice, you will be able to identify these patterns, and like what all can you use. There is only like a finite number of things that you can use. So yeah, that's it. I will share the link to this code so that you can play with it yourself, and also but try to practice this problem on your own. Try to write code on your own first, and then if you can't, if you feel like you're not able to get the solution, then you can look up the solution. But I would highly recommend to first try it on your own. So that's it. See you next week. Bye.